Hey calculus kids, welcome to week 8 Tuesday. I'm so sorry I'm not there with you in person. I had a last minute appointment that I had to rearrange for, so I am not present for period 1 and 2 on week 8 Tuesday, but I will be there for after period 2 and the rest of the day. So sorry about that, but I hope you guys had a wonderful fall break. And if you're watching this, you should be caught up anyways. It's completely fine. You're not going to be missing on any of the important skills that we need to cover today in class. So go ahead and pause the video and go ahead and answer the following 3 questions. Keep in mind that today is week 8 Tuesday and your warm-up log for 100 boxes is due on week 9 Friday, so next Friday. This actually is a review of Monday's material, so I'm kind of gonna just kind of go through it briefly. All right, let's go ahead and get to today's stuff. Last time I saw you guys, we talked about the product and quotient rule. Today, we're gonna dive a little bit deeper with product and quotient rule with trig functions. The thing about this class is it's kind of like building a house. We need to go ahead and make sure the foundation and the pouring of the concrete is very stable before you put up the walls of the house. And so when you fail to go over, like, let's say week 8 Monday's material on the YouTube video, if you're not here with me in person, then today's material will be even more difficult than yesterday's because it is kind of built on the fact that you already understood the stuff that we went over yesterday. And so that I can build on more, like the roof of the house. And so it's really, really imperative that you keep up with the class, with the pacing of the class. And when I give you guys, like, let's say yesterday, the flashcards and I ask you guys to memorize them, make sure you take the initiative to do that because this class does get more difficult and complex. And if the foundation of your knowledge when it comes to calculus 1 is very wobbly, then as we get closer to algebra, or excuse me, calculus semester 2, the entire house will eventually just collapse because you don't have the foundations set yet. So make sure you are keeping up with the pacing of this class. And although you might be at home on some of the hybrid days, please watch the video and fill out the guided notes in your packet because that is critically important in the success of you passing this class. And then also, more importantly, passing the AP calculus test for in May. So anyways, let's go ahead and go over this. I'm going to go over my notes on guided notes on product and quotient rule with trig derivatives using product and quotient rules. So today we're going to talk about higher levels of product and quotient rules, product of quotient trig rules, product of quotient rules with trigonometric functions. I do have a Quizlet right here on flashcards. Yesterday, which was Monday, we went over the flashcards that we cut out. But if you did not do that, I do also have them on this tiny URL on Quizlet, which might be a little bit easier on your cell phone if you have access to it to memorize. So before we go ahead and get started with today, I am going to have you guys do a little bit of practice. So if you just get out a piece of paper or a dry erase board, that works as well. So go ahead and turn over to your notes today. Today is week 8, Tuesday. Here are some additional practices. These are the questions that we're actually going to be going over first. Then I have a practice on velocity and particle motion. If you need the steps and answers, here they are right here. You just need to go ahead and type that Google link in. Make sure you do the capitalization. All right, so let's go ahead and just jump right in with some of the practices. Question number 1. You're given that g of x is equal to the square root of x, 4 minus x squared. So you could technically use the product rule, but if you don't want to, there are other ways that you can avoid that from using the product rule. So the first thing I'm going to do is I'm going to go ahead and rewrite this to x to the 1/2. And then what I can do is I can take that 1/2 and then distribute it into the parentheses. So I have 4x to the 1/2 minus x to the 1/2 times x, and I can do 2 right there. Okay, and this is g of x still. So if I look at this part right here, I'm going to have to add these two fractions together. So 1/2 plus, I know I need to have a common denominator, so 4/2 is going to be a 5/2. And that is g of x. Now, in order for me to find g prime of x, or g prime, I can apply the power rule, bring the 1/2 down. 1/2 of 4 is 2x, minus 2/2 is a negative 1/2, minus the same thing with 5/2, x minus 2/2, which is a minus 1, is a 3/2. So then if I go ahead and rewrite this, I will have g prime is going to be equal to 2 over the square root of x minus 5/2. And you can write this in radical form if you want, x to the third, or square root of x to the third. And this will be your answer. Now, on the other hand, if you rather do the product rule, you could do something like x to the 1/2 times 4 minus x squared. And remember the product rule, I just put PR, is going to be f prime times g minus f times g prime. There are 4 components of this. F, so I'm going to have f be the first part, which is just going to be x to the 1/2. F prime is 1/2 x to the negative 1/2. Third part is for you to find g. So g is going to be 4 minus x squared. And then the fourth part is g prime, which the 4 becomes a 0, so it's just a negative 2x. So let's go ahead and move forward with that. G prime, and it's unfortunate because I have a g prime right here as well, so maybe I should put g prime of x, so that way you don't get that confused. So g prime of x is going to be f prime times g. So that's going to be 1/2 x to the negative 1/2 times g right there. So I will have 1/2, bring that x down to the 1/2, times 4 minus x minus 2. So that's going to be 4 minus x squared. So 4 minus x squared, not x minus 2. Sorry about that. Plus, next part that you're going to have is going to be f times g prime. Sorry, that's a plus. I don't know why I put a minus. I'm thinking about quotient rule. It's product rule still. F times g prime. So then here you have negative 2 times that, so it's a negative 2. X times x to the 1/2. Remember common denominators. You add them. That's x to the 3/2 power. And that is your answer. I know you're like, well, this doesn't really look like what I had before, but if you were to go ahead and find the common denominator here and combine them together, you will have the original answer, the previous answer. All right, let's go ahead and take a look over here. Question number 2. So with this one, you would have to go ahead and use the quotient rule. So QR, F, which is going to be the top right there, is just going to be cosine of t. F prime, and you should know that the derivative cosine is a negative sign. So negative sine t. Your g is going to be the denominator, and that's t to the third. So then your g prime is 3t squared. But you actually have one extra component, which is g squared. So that's going to be t to the third squared. So you have to multiply the exponent. So that's t to the sixth. Now that you have these five things, f, f prime, g, g prime, and then g squared, you can go ahead and plug this into the formula. So the quotient rule is going to be f prime of t is equal to f prime times g minus f times g prime all the way over g squared. So let's go ahead and plug that in. F prime times g is going to be a negative sine t times the t cubed. So I'm going to put the t cubed in the front so I don't mistake the t cubed with the t with the sign, minus f times g prime. So that's going to be a minus 3t squared cosine t all the way over g squared. So that's t to the sixth. Now, as I'm looking at this, you could say, okay, well, that's my answer. But if you're doing a multiple choice question, they might not have this as an answer. And the reason for that is because you can actually factor this out a little bit. What do they all have in common in the numerator? Well, I can see that you can probably factor out a t squared. Or better yet, let's see. Yeah, a t squared. If I take out a t squared here, I will have a negative t sine t minus 3 cosine t. So my t squared and the bottom cancels because if I move that to the bottom, if I move the square to the bottom, t to the sixth minus 2 is going to give me t to the fourth power on the bottom. And then on top, you could factor out a negative 1 if you would like, just to make it look a little bit aesthetically more pleasing. It'll be t sine t plus 3 cosine t. And that is your answer. And again, it all depends on how the multiple choice is presented, but you should be able to kind of go back and forth with this if you understand the problem correctly. All right, let's go on to the next one. Number 3. And again, you can just copy this part down on a separate piece of paper. Now, as I'm looking at this, I'm like, I really don't think you want to do the product rule because look how ugly g is going to be. It's 1 minus 2 over x plus 1. That is absolutely hideous. So before you just attempt to run into either a quotient rule or product rule, see if you can go ahead and maybe like rearrange it a little bit algebraically to make it a little bit more simple. So let's go ahead and first distribute that. So I have f of x is equal to x to the fourth minus 2x to the fourth over x plus 1. And then after that, you can just actually apply the power rule for the first one. So bring down the 4. So that's 4x to the third. So boom, check, that is done. Minus the derivative. Now you have to tackle the second part. And the second part, you will have to use the quotient rule because you won't be able to escape that. So for the quotient rule, remember, you will need to have the first part, which is going to be f. That's going to be my numerator. And I'm just going to go ahead and put a negative on the outside. And I'm going to keep everything in the fraction positive. So that way I don't get that messed up. So f is going to be 2x to the fourth. That's the numerator. So then g is going to be 8x to the third. I'm sorry, f prime. Hello, hold on. Sorry about that. G is the denominator, x plus 1. So g prime is just 1. G squared is going to be x plus 1 squared, or if you go ahead and FOIL that, you have that part right there. All right, so let's go ahead and plug in the formula. And I'm going to do it on the side just because I don't want to mess up this entire thing. It'll look really messy. F prime times G minus F times G prime over G squared is a quotient rule. So let's proceed forward with that. F prime times G. So that's just this part right here. And that is going to be 8. I'm going to distribute it. X to the 4th plus 8x to the 3rd minus F times G prime. Well, that's a pretty easy one. So yay, that's good for us. Okay. Can I combine anything? Yes, I can. That's going to give me a 6x to the 4th plus 8x third divided by G squared, which is going to be x squared plus 2x plus 1. And my pen is not working, it's glitching. So far right now, I don't see anything that I can cancel. I have x to the 3rd on top and then like x to the 4th on the bottom, but that's okay. I'm just gonna keep it as is and I'm good with it. So let's go ahead and move that forward. You're gonna take this entire thing and bring it down here. The only other thing that I can think about maybe rewriting this is if I could factor out maybe a 2 from the numerator. If I take out a 2, I will have a 3x to the 4th. Actually, I could take out a 2x. Actually, you know what? I'm not. I'm just going to keep it as is. It's fine. There's no point. It's not canceling anything. Minus 6x to the 4th plus 8x to the 3rd over x squared plus 2x plus 1. And that is your answer. You can go and rearrange this however you want, but to me, I think looking at it, this looks like the most simplified way that I can do that. You can proceed forward by having a common denominator, but unless the multiple choice questions actually show you that and have that, this is how I will leave it. All right, let's go ahead and take a look at this one here. So with this question, you really have to use the quotient rule. There is nothing that you can do to rewrite it to make it look better. So let's just continue with that quotient rule. F is for x, F prime is just 4. G is going to be 1 plus x squared. G prime is 2x. And then G squared is going to be 1 plus x squared squared. You would have to FOIL this. So first is going to be 1. Outer is 1x squared, inner is 1x squared, so 2x squared when you combine them. And last is just x to the 4th. All right, so let's do this. F prime of x is equal to f prime times g minus f times g prime divided by g squared. So then f prime times g, or I'm sorry, yeah, f prime times g, I'm going to miss the 4 right there, is going to be 4 times 1 plus x squared. So make sure you distribute that, 4 plus 4x squared, minus f times g prime. So here is f times g prime, which is going to give you, and my pen is glitching, that's okay, 8x squared. I can go ahead and simplify that. So I have a 4 minus 4x squared all the way over g squared, which is going to be a 1 plus 2x squared plus, oh, and you know what? I just noticed this, that it would actually be more beneficial if I kept my denominator without foiling. If I actually just have 1 plus x squared times 1 plus x squared. And the reason I say that is because if you look up here, I both have a 4. So if I factor the 4 out, actually that wouldn't work. Never mind. Minus x squared. I got a little excited, but you can't cancel that. I thought you could, but no, you can't. All right, so then this is your answer right here. And that is your f prime. There we go. All right, so next what I want you guys to do is go to your guided notes. On your guided notes, you have this part right here. And you have a few practices with A, B, C, and D. I want you to go ahead and see if you can figure out how does the derivative of tangent x equals secant squared x? How does the derivative of cotangent x equals negative cosecant squared x? Go ahead and give that a try. And then when you're done with that, take a look at example 2, example 3, 4, 5, and 6. And if you need the steps, they are shown right here on this link. Be careful with the capital D. And if you need a reminder, here are your formulas for the derivative. So I'm going to go ahead and help you guys with the first one. So let's take a look at A. And again, if you need the steps, it is available for you. Okay, so with A, here the derivative of tangent x. Well, what is another way of writing tangent x? You should know that from the flashcards and also from trigonometry, that you learn different ways of rewriting trig functions back and forward, backwards and forward. And so in this class, you'll be doing the same thing. And that's why it's really, really important that you memorize your trig functions. And if you have not done so, yesterday, which was Monday, I gave you guys the flashcards that you cut out, and you will need to go ahead and memorize that in addition to the derivatives of those trig functions. Next semester, we're going to start learning about the integrals of trig functions. So you literally have 3 sets of memorizations that you would have to do. And so it's important that you pace yourself now. You should have learned your trig functions from last year. First semester, you should learn your derivatives of trig functions. And then second semester, you should learn about the integral of trig functions. So pace yourself. You cannot expect to memorize all of this a week before the AP exam. It just doesn't work that way, you guys. All right, so another way of writing tangent x is going to be sine x over cosine x. And then from there, you can go ahead and use the quotient rule, okay? So then your f is going to be the numerator sine x. F prime is going to be a cosine x. G is cosine x. G prime is negative sine x. And then g squared is just cosine squared x. Now that you have these 5 components, remember your derivative is going to be f prime times g minus f times g prime over g squared. So let's go ahead and fill out this formula. F prime times g, that's cosine times cosine. So I'm going to put cosine squared x. There's 2 of them. Minus f times g prime. So here is f times g prime. And so a double negative is going to give me a positive, and there's 2 signs. So sine squared x over g squared, that's cosine squared x. And as I'm looking at this, I'm like, that doesn't look anything like secant squared x, but I can go ahead and use my trig functions to rewrite this. Because I know that cosine squared x plus sine squared x divided by cosine squared x is going to give me a 1. Because remember, cosine squared x plus sine squared x equals 1. right? Back in trigonometry, 1 over cosine squared x. Oh my goodness, come on, work. And that cosine squared now did not change, it just got transferred over there. And what is 1 over cosine squared x? Well, the last time I checked, 1 over cosine is going to be a secant x. Or in this case, secant squared x. All right, you guys try B and C on your own and give it a try to see where you end up with that. I'm going to go ahead and go over D with you guys. So let's skip over to D. And again, if you need answers for B, here's the answer for B. Take a look at that. Actually, I'm going to go over C. So you guys go over D. So let's go over C first. So looking at C, you want to figure out why does the derivative of secant x equals secant x tangent x? Well, let's give that a try. Well, the f of x of secant x, another way of writing that is just 1 over cosine x. Well, if I go ahead and bring this cosine x up, it will be a cosine x to the -1 power, just by rules of exponent. So let's go ahead and find the derivative of that. So f prime equals, and you're just going to do the power rule. So take the -1, bring it down, and that's going to be a cosine x minus a 1, so it's a -2, times, you have to multiply the derivative inside here, which is called the chain rule, which we haven't gone over yet, but this is a good little preview. So you have to time the derivative of inside the parentheses, and that's where the chain happens. So what is the derivative of cosine x? It is going to be a negative sine x. So that is your chain. This part right here is a chain. So now let's go ahead and rewrite this to make it look a little bit better. Because right now, what I have does not look anything like secant x, tangent x. I know this has a negative exponent, so I am going to have double negative, which is a positive. And I'm going to have the cosine x move down to the bottom. So cosine positive 2x because it got moved down to the bottom. And then what's on top is I have a sine x. And my pen is glitchy. Here we go. Okay, I can go ahead and expand this. Sine x over cosine x times 1 over cosine x. So I went ahead and expanded it, and then also split it into 2 fractions. And that's totally fine because I'm not doing anything illegal. Okay, so then sine x over cosine x is going to give you a tangent x. Whew, that looks a little bit better. Got the tangent x. And then 1 over cosine x is where your secant x happens. Now this is just a commutative property because a times b is the same thing as b times a. So I'm just going to rewrite it. So secant x and tangent x. Now you go ahead and try D and see where you get with that. Here are the answers for D. All right, you guys, if you would like to practice with chain rules and maybe go a little bit further, I do have a few extra questions, example 2, 3, 4, 5, that you can practice with. We will eventually go over more complicated chain rules and whatnot, but as always, you have the link right here to check any of the examples 2, 3, 4, 5, 6. And I will see you guys next time. I hope you guys have a great day. And as always, stay safe and healthy.